Hello again and welcome. I thank you for joining me. Today, we're going to look at Lesson 3 in our Learn to Program in Java series. Lesson 3 picks up where Lesson 2 left off. In Lesson 2, if you remember, we looked at variables, data types, and the assignment statement. And in this lesson, we're going to look at how you can convert your data from one type to another, both implicitly and explicitly, as well as how you can take string data and convert it into intrinsic types like integers, doubles, and Boolean values. Along the way, we'll also look at concepts like syntax errors and semantic errors. Let's get into it. Through our agenda today, we'll use two distinct examples. In the first example, we'll look at what happens when you write a program and the intent isn't what you expect. Along the way, we'll look at various operators and how they're affected based on the data type you chose. And we'll also observe what an error in syntax is versus what an error in meaning of your code, or semantic errors. And the final part of the first example, we'll explore how you can explicitly convert string data, that is sequences of characters, into types like integers and doubles. Then in the second example, we'll explore casting. Casting allows us to convert our data on the fly from one type to another, and this can either be done for us on behalf of the compiler or explicitly through a command, and we'll look at both ways of doing that and look at the pros and cons of each. It ought to be interesting, so let's get started. As you can see, I have my NetBeans environment up and running, and now I'm going to start by creating a new project by pressing Control Shift and N. This opens up the new project window. I'm going to select Java application. The name of my application is going to be 1 plus 2 equals 12. This will make a lot more sense once you see the example. First, let's start out by exploring the kinds of errors you can have in a program. For example, if I type in string x equals 1 and I run this program, the program builds and then executes, no problem. But if I have some kind of error in here that prevents the code from building, and I hit F6, I'll get this error that says one or more projects compiled with errors, right? So when you have a compilation error, that is an error that prevents Java from converting the source code into bytecode, we usually call that a syntax error, an error in syntax. That is, you didn't express the language correctly and it's throwing an error. Syntax errors are pretty easy to catch, and most of the syntax errors that you encounter will show up interactively as you type in the NetBeans IDE. This is yet another advantage of using an integrated development environment over just coding up in a text editor like Notepad. Let me continue on with the example. String y equals 2. And now let me just say something really simple like system out println x plus y. Now under normal circumstances, you would expect when you see x plus y and they're both variables, for those variables to be added together. So in this case, I have a 1 and a 2. I would expect my result to say 3. You can see with the code that I've written, there's nothing wrong syntactically with that code. The syntax of the code is fine, right? This will build, no problem. So if I go up to run and I say build project, which is F11, it builds just fine and there's no problems at all. It takes my Java and converts it into a jar. No big deal. However, when I run the program, the intent, that is what I expect to happen, doesn't match up with the result. 1 plus 2 is 3 in most universes, but here it's 12. And that's because I've introduced a bug in my program. And the bug that I've introduced is that since 1 and 2 are strings, this plus no longer means addition, it means string concatenation. In other words, take x and take y and append them to each other and make one large string out of them. So what I wanted to happen in my code isn't what really happened. Those are called semantic errors, errors in interpretation of what the code should do. These are obviously the harder bugs to catch. Later on in the course, we'll learn ways that you can write code that helps you catch semantic errors. All that being said, this plus operator is fairly useful. For example, let me put this together. String first name Michael, string last name fudge, system out print, first name plus last name. Let's run that. So I get my 1 plus 2 is 12, and then I get Michael Fudge concatenated together. I can kind of beautify this up with some literal strings as well. So I could say first name plus a space plus my last name plus a couple of exclamation marks. And then when I run that, I get Michael space Fudge last name exclamation marks exclamation marks. Pretty neat. This, of course, doesn't help us solve the original problem, which is we have a bug where we want 1 plus 2 to equal 3, yet they equal 12 because of string concatenation. The whole point is that let's figure out how can we convert our string back into an int. At this point, you might be thinking a little ahead and saying, well, why can't I just do something like this? Int I is assigned 1 as a string, right? And then it'll take this 1, which is a string, and convert it to an integer 1. But you can see already that this is going to generate a syntax error. It says incompatible types required int found string. And this happens because, again, I'm trying to take what is a string and putting it inside this integer variable. These are incompatible types. Typically, what you want to do in this case is you need to use a method of the integer class to parse the string into an integer. For example, maybe I want to take x and put it into I. I would say integer.parseInt x. Likewise, I could say int j integer.parseInt y. Now the values that were in x and y as strings are now stored in I and j as integers. And then when we do system out println I plus j, we get exactly what we would expect, which is a 3. It kind of helps to maybe trace through this. So I'm going to start this again, but this time I'm going to use the debugger. I'm going to step through it line by line. So right now I have x and y, they're both strings, and now this is going to make an I and a j, and I is equal to the value when you take the integer and parse it, and then I gets the value of parsing the value of x, which is a string, but treating it as an integer. So instead of 1 with quotes on it, I get 1 like that. Same thing happens with j. See, it's 2 up here for y, and then 2 without the quotes down here for j. And then that's why the execution works. Now, this example is great and all, but it kind of brings up a point. It's why not just use, why use strings at all? Why not just use integers? And I guess the point of the exercise was to show you, number 1, how to convert strings into integers, and number 2, how to deal with unintended consequences in your program. As you might expect, there's also a way to do this with double values. So here's another example. I might say string GPA 3.96, then double GPA 2 is assigned double dot parse double. It's not parseInt anymore, it's parse double GPA. And now this GPA here would be just a series of characters 3.9.6. This GPA2 is actually the value 3.96. I can actually apply math to it and it works as expected. For example, this generates an error. This is a syntax error because it doesn't know how to apply the minus operator to a string and a double. But this would work because I'm applying the minus operator to a double and a double. And then when I run it, I should get 2.96, 1 point lower than my original GPA. All right, well, that's our first example. And again, this is just kind of introducing you to the concept of how do I convert string values into other types, and also how do I deal with errors in semantics. In this next example, we'll take a look at how operators deal with values of the same type and values of different type, and then how you can force a type over an operator. We call that casting. I'm going to start a new project, Control-Shift-N. This one I'm going to call Understanding Typecasting. All right, let's stage this example. If I were to ask you what 20 divided by 15 was, and you used a calculator, the answer you would get is 1.333333333, right? That would be your answer. Armed with that knowledge, let's see what Java tells us the answer would be. So in this case, we are dividing an int by an int, and we want to know what's the type of that. Any takers? Is it going to be a 1 or a 1.33333? Well, let's take a peek. Run that. When you divide 20 by 15, they're both integers. The result is an int. See, the value is 1. And this is pretty consistent with how most programming languages work. If you have an operator that has the same type in that operator, the result is always of the type of the operand. So if I take an int and multiply or divide it by an int, I still get an int. So then the question becomes, well, how can I make this be this answer? So you say, well, what if I did something like this? If I said double d1 gets x divided by y. So now we have int divided by int. That's going to produce an int, and then that's going to go into a double. What's going to happen here? Are we going to see 1.0 or 1.33333? Let's find out. Run that. You see I get 1.0. So it's still preserving type. Int divided by int is int. Then it's stuffing it into a double. So it's getting implicitly casted from int to double. Still didn't do what we wanted, right? What we wanted to do was get the real answer, 1.33333. How about if we do it this way? What happens when we take an int and divide it by that? First of all, this is an int here. So what we're doing is int divided by double times int. What happens here is you get type promotion. So double times int produces the more flexible type of double, and then int divided by double produces double. So the result here is going to be a double. This is known as an implicit typecast because we didn't have to tell Java to promote the type from int to double. It does it automatically in order to handle the complexity involved in the math operation. There we have it. This looks really noisy and awkward, so a lot of people might ask, is there an easier way to just get the same results without having to do this crazy thing where I multiply it by a constant double value? And of course the answer to that is yes. This is where the explicit typecast comes in. You say double d3 equals x divided by double y. What this here says is take y as an integer and then convert it to a double, and then take this integer x and divide it by that, which the result would be promoted to a double. So this is int divided by double is double. But it does exactly what we expect, which is treat this value y as a double rather than treating it as an int. And then, of course, our division works as expected. Let's print that out, see what we get. And you see we get 1.33333. So that worked as expected. This is generally, line 12 is the pattern that you use when you have two ints and you want to get back a result that's a double. You take one of the ints and cast it as a double. You can either cast the numerator or the denominator. It does not matter. But you cast one of them, and then you get the result you expect. This leaves us with one last thing to consider. What happens when you have a more complicated type and you try to implicitly cast that as a simpler type? Will that work? For example, what if I tried to do this? Int W is 3.14. You'll see this generates a syntax error because there's a loss of precision. And this brings up an interesting point, is that you can implicitly cast ints into doubles, but you cannot implicitly cast doubles into ints because you're going to lose important information about the number. For example, if I typed double W gets the value 3, it has no problem with that because it can easily promote a 3 to a 3.0 and not lose any precision. However, the reverse is not necessarily true. Bottom line here is it's okay if you say, double variable gets the value and it's an int because it will be implicitly converted for you into a double value. But the reverse is not true because you will lose precision. And of course, it's not smart enough to understand that even if you did this, that 1.0, the dot 0 is not significant. We can just chop that off and it still would be a satisfied int. It's just not smart enough to do that, nor should it be. The onus of that is on you as the programmer. Well, that concludes our lesson 3 on syntax and semantic errors and casting and converting data of various types. Join us for our 4th lesson where we look at objects and methods and how to use classes that are in the Java class libraries. It ought to get interesting. Thank you very much, and again, I welcome your questions and feedback on YouTube. Goodbye now.